you very much. I do need some participation, guys. I really appreciate it when you pitch in here. So when you say factor, look at the top. I think I can take out a 2. And now I can factor that trinomial and that trinomial. So I'm going to have, let's see, that one's going to be x, minus, or x minus 3 plus 2. And the one on the bottom is going to be x minus 3 minus 2. Does that look okay to everybody? Good. So step 1 is factor. Okay? Now, what do you notice about the factorization?
There's going to be a hole.
There's going to be a hole because we can cancel. So we are actually going to be sketching 2x plus 2 over x minus 2. That's the equation that we're actually going to draw a picture of. But because of this, our picture is going to have a hole at the point where x is 3, because that's what I canceled out. So then how do I find the other part of that point? There's obviously it's a point, it needs a y. How do I get the y?
You plug 3 back in.
Yep, I'm going to plug 3 back in, so I'm going to have 2 times 5 over 1, 10. Is that right?
Yeah.
So 1, 2, 3. Oh, okay. Well, good thing I'm not on my couch today. We'd be in trouble. There's the point 310. Now I'm going to refocus my attention right here, and I'm going to start graphing that. So what do you notice about this now? This is where we're looking. We're really not looking at the original anymore. What do you notice about it?
The horizontal asymptote, I think.
Okay.
Would that be 2?
It would be at 2. So we have a horizontal asymptote at y equals 2. Notice, guys, there are some blanks there for you to fill in. Now, it doesn't say horizontal asymptote. It says end behavior asymptote, because if these powers don't match like this, sometimes we don't get a horizontal asymptote, right? So horizontal asymptotes are special end behavior asymptotes. So where it says end behavior asymptote, you're going to write y equals 2. It happens to be horizontal this time because these powers match. All right, and obviously 3, 10 goes in the blank where it says whole. All right, so what else do you notice about your equation?
The vertical asymptote is 2.
X equals 2, perfect. So make sure you label it x equals 2, and when you write it in the blank where it says vertical asymptote, make sure you write x equals 2. All right, if you ever get confused, when you draw a vertical line, it crosses the x-axis, x equals. All right, what else do you notice about it? Well, what else do we need? We're missing some pretty important stuff. What are we missing?
And y-intercept.
Yeah, we're missing the intercepts. Now, remember, the intercepts are points that we find by just letting each coordinate be 0, right? One at a time. So if you let x be 0, put in 0 for x, right here I'm finding this point. If I put in x, or 0 for x, I'm going to get 4 over -2. If I put in a 0 here and a 0 here. So my y-intercept is 0, -2. How do I know that's the y-intercept? When I plot it, it's on the y-axis. Now, what happens if I let y be 0? So now I'm going to have the equation 0 equals 2x plus 2 over x minus 2. When I cross multiply, this is going to give me 0, and this is going to give me 2x plus 2. What do you get when you solve that?
-2?
Yeah, so you get the same thing, only now it's on the x-axis. And I've been calling that an x-intercept, but what's another name for x-intercept? Look at your quiz paper there. What's another word for x-intercepts?
0.
Yeah, that's what your calculator calls them, right? When you go to second calc, 0 is where it crosses the x-axis, right? So 0 is just another name for x-intercept. All right, so we'll do the limit stuff here in a minute, but right now, that's enough for the graph. That's everything we need for the graph. So, can you tell what it looks like? Can you visualize it? I think I got this right here. Would you agree with that? And then what else do I have? If you stop there, you're in trouble because you're missing half your picture. Where's the other half?
The right side
Yep.
up top.
Yep,
Where the hole
right
is.
side up top, where the hole is. Yep, I missed him. Yep, goes right through the hole. Thank you. Perfect. Beautiful picture. Anybody have a question about the picture? Because now we're going to use that picture to answer the rest of the questions. All right, number 6 on the quiz says the limit as x approaches infinity. Now, when we're talking about x approaching infinity, we're talking about out here, right? This is where x is approaching positive infinity. What is happening to our curve as we approach positive infinity?
It's getting closer
To what?
to the infinity line.
Well, x approaches infinity is down here on the axis. Your curve isn't really getting, well, I guess it sort of is getting closer to the axis, but what it's really doing is getting closer to this asymptote, isn't it?
Yeah, sorry.
Yeah. So the answer to number 6 is 2 from the top. The function values are approaching 2 as you go out toward the left, or excuse me, the right, this is right. As we're heading toward the right, the curve is going down, getting closer and closer to 2. So since it's on the top of 2, we put that little plus sign. Remember that conversation we had the other day? All right, now number 7 says, what happens as we approach 0? Now, x is approaching 0. Guys, right here is where x is 0, right? And we are approaching it from the right side, from the positive side. So jump on your curve and trace it, getting closer and closer to where x is 0. This is where x is 0. So I'm tracing my curve. What is happening to my y values? What are my y values doing?
They're getting closer to the 0 plus, 0 positive.
Well, yes, I'm heading toward this. That's what the problem says. My x's are getting closer to 0. I want to know what my y's are doing. What are my y's doing?
They're becoming more negative.
They're becoming closer to -2. Guys, I don't know what's going on. You're making this way harder than it is. As I get, here's where x is 0, right here. All right? So as I get closer to the green line from the right side, what are my y values doing? They're getting bigger, right? Aren't I going up? I'm moving that way. Aren't I going up? And as I'm getting closer and closer and closer to the green line, my y values are getting closer and closer to -2. And if you look at the problem, that is what it is saying. It is saying what happens as x does this, what happens to y? What happens to that? Well, it gets closer to -2. Let's look at the next one. The next one says, number 8 says, we're approaching 2. Now 2 is right here. So we have an asymptote now, an asymptote. As we approach 2 from the left side, so we're getting, here's our curve, get on your curve, head toward 2 from the left side. What is happening to your curve? What is happening to your y values?
It's getting closer to 2.
No, the x values are getting closer to 2. What are the y values doing? What's the y value here and here and here and here? What are those y values doing?
-infinity.
Exactly. Guys, the problem tells you that x is approaching 2. I don't care. That's fine. I want to know what is happening to y. Y is going down. All right, number 9. Now we're letting x go to -infinity. So now we're going out this way. What is happening to your curve, the y values of your curve, as you let x just keep on going that way? What happens? What are your y's doing?
They're getting closer to the 2.
Yep, only this time they're coming in from the bottom. They're coming in under 2. They are definitely getting closer to 2, but they're coming in on the bottom side. That's negative, on the negative side. Over here, they were coming in from the top. So on both sides of the picture, we're approaching 2. As we go off the page, our curve is getting closer to 2, but here it's on the top of it, here it's on the bottom of that asymptote. All right, now what's number 10 say? Number 10 says, come back over here. Now we're going to let x get closer to 2, but this time we're going to come at it from the right side. So as you look at your curve on the right side of 2, what happens as you move toward 2? Yes, you're getting closer to the asymptote. That's what you're supposed to be doing. But what's happening to your curve as you get closer to the asymptote?
Like a positive infinity?
Yep. So number 10 is positive infinity. The curve is going up. It's shooting up into space. On this side, it was shooting down into space. So we said negative infinity for this one. All right, now 3. Now we're going to let x approach 3. Now, here's where x is 3, right here, right? As we get closer and closer to 3, as the x's, think of all these points, as the x's get closer and closer, oh wait, I'm sorry, I'm doing number 12, because I'm coming from the positive side, so this is number 12. As x is getting closer and closer to 3, from the right side, from the positive side, what is happening to my y values? Every step I take, my y values get closer to what?
10.
Yep. So the answer to 12 is 10. Now what about 11? What happens as you approach 3 from the negative side? So my picture's not very good, but we're coming in on this side of 3. As we come closer and closer and closer, what's happening to my y values? Kids, aren't the y values getting closer to 10 on both sides?
Yeah.
Yeah, so the answer is 10. When you have a point, like this one, or that one, or this one, any point, as you come at it, both sides are coming to the same place. You're coming to the same number. So here, no matter which side we came from, our limit would be -2. Here, no matter which side we came from, our limit would be 2. Here, no matter which side we come from, our limit is 10. It's only when your picture is broken by an asymptote that you can have 2 different limits on either side. These are called one-sided limits. But when you have a point, the limit's the same. No matter which side you're coming from, you're ending up at that same point. So the limit towards 0 from the right or from the left would be -2. The limit toward 3 from the right or the left would be 10, because both sides of the curve are coming together at the very same point. All right, you guys seem to have a better grasp of this the other day. Let's turn it over. There's another one on the back that's exactly the same. I think even the numbers maybe are the same. So let's give a shot. Let's give this one a shot and see what happens back here. All right, how did we start the problem?
Factoring?
Yep. And we're always going to factor because that is the only way that we will discover what?
Any holes?
Yep, that's right. You will not be able to look at the problem and tell if there are any holes. You're going to have to factor it to make sure. So here's my equation. I'm going to go ahead and factor. So it's x minus 3 plus 1. Oh, okay. So what does that mean? In the blank that says holes, we'll simply write none. Because nothing cancels, right? So what do we have? We don't have any holes. What are some things that we do have?
A vertical asymptote.
Mm-hmm. And where is it?
X equals.
Did you say 2? I hope you said 2. You kind of cut out there. X equals 2? Now, what else do we have? We got a nice vertical asymptote there. What else do we have?
Do you have an end behavior?
Yeah, I'm not going to
Okay.
have a horizontal asymptote because the power on top is bigger than the power on the bottom, right? So there is no
Yeah.
horizontal asymptote, but I'll do my division and see where my end behavior asymptote is. So I'm dividing by x minus 2, so I'll put a 2 out here. Here are my numbers if I copied them right. So what does that tell me? Where's my end behavior asymptote? This part right here tells me. What does that say?
Y equals x?
Yep, y equals x, technically plus 0, but you can just say y equals x. So that is my end behavior asymptote. So that is the identity line, y equals x. You graphed it many thousands of times. There it is. So there are my asymptotes. Okay, what about intercepts? I find my intercepts by plugging in zeros, right? So can somebody tell me what I get when I let x be 0?
Negative 3 halves.
I get positive 3/2 if I let x be 0, because I have a negative over a negative. So positive 3/2, 1.5. There's my y-intercept. I'm never going to be confused about which one's x and which one's y. I'm going to plot it. The minute you plot it, you see that's your y-intercept. Okay? Now, I'm going to let y be 0. So I'm going to go back to my problem here. I like the factored form for this. I'm going to put in a 0. I'm going to cross multiply. So this gives me 0. And this gives me x minus 3x plus 1. 0 times anything is 0. 1 times anything is itself. So what does that mean my x-intercepts or my zeros are?
3 and negative 1.
Yep. So I've got x-intercepts at 3 and negative 1. So I got one here, and I got one here. So my intercepts and my asymptotes are in there, and we don't have any holes. So I'm just going to go ahead and sketch the curve. Do you get a sense of what it looks like? Can you get a feeling for what this looks like based on the points that you have? Would you agree with that? And then over here, remember, as it goes farther and farther, it's going to get closer and closer to its asymptotes. All right, everybody okay with the picture? So we got the first 5 already filled in, right? So now we're going to start doing our limits. Okay. So number 6 says, what's the limit as x approaches infinity? Now, what does that mean? Approaching infinity means we're going to the right, right? We're going that way. So let's jump on our curve and let's start going to the right. What is happening to my y values as I keep moving my finger to the right?
It's going towards positive infinity.
Indeed it is. It's going up, 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 up. It's heading toward positive infinity. As you are going to the right, as you start marching to the right, every step you take, that thing just keeps getting bigger and bigger and bigger. When we had a horizontal asymptote, it kind of had a cap on it. This is not going to cap it. This is just going to let it keep going bigger and bigger and bigger.
It's forward.
Yep.
So
Yes.
when you're doing, how do you know which line to look at?
What do you mean?
Like you looked at the line on the positive side, like why not the one on the negative?
You mean why not this one?
Yeah.
Okay, because the problem says I'm finding the limit as x goes to infinity. This always tells me where to look. Where does x approach infinity? On the right side or the left side?
The right side.
That's why I looked on the right.
Okay.
This tells you exactly where to look. Okay, so where's the next one telling me to look? The next one is telling me to look toward 0 from the positive side. So here's 0. This is where x is 0, right here. What's happening to my curve? What is happening to my y values? Limits are y values. What's happening to my y values as I approach from the right side of 0? As I head toward this green line, which is 0, what happens to my curve?
It goes through 3 halves.
It goes to 3 halves. The answer to the question is 3 halves. The limit is 3 halves. You guys, even if you're confused by this, I just told you. Limits are y values, and when you have a point, which is exactly what we have right there, no matter which side you come at it from, the limit is the same, because there's one y value there. All right, what's A?
How do you know whether to put the plus sign above the number?
We don't generally when there's a point there, but if you put a little plus there, I wouldn't mark it wrong. You're never going to see anybody ever do that, but I understand your question. We don't do it when it's a point, basically. When it's coming to a point. If it's heading toward an asymptote, yes, but usually not toward a point. All right, the next one says, the limit as x approaches 2 from the negative side. Here's 2. We're going to get on our curve and come in from the negative side. What is happening to my y values?
It's infinity?
Positive infinity. As you follow this purple line, which is my curve, and get closer to x equals 2, because that's what the problem says. The problem says approach 2 from the negative side, so that's the left side. So we come in, my pencil's just going up, 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 forever. Closer I get to 2, the higher it goes. Positive infinity. Uh-huh.
So when you say the y values, are you talking about the points on the line? Is that what you're talking about? Like the different y values on the points of the line?
Absolutely. Okay. Absolutely.
Okay.
I'm talking about that curve. So as the x points get closer to 2, the y points just keep getting bigger.
Yeah. All right.
Number 9. What does number 9 tell me to, or where does number 9 tell me to look? It says right there in the problem, x is approaching negative infinity. Where does that happen? Where does, on the left. So I'm looking at the left side of my picture and I'm going left. I'm going left as far as I can. So all these x values are going left. What are the y values doing?
Negative infinity?
Yep, they're going down. Every single one of these is going down farther and farther and farther. My finger right now is going left and down. The problem told me to go left. The answer is I'm going down. Number 10. Let x approach 2. Here's 2. Let x approach 2 from the positive side. Let x approach 2 from the positive side. All right, so here's 2. Follow your curve, getting closer and closer to 2 on the right side over here. What's happening to your function values? What's happening to y?
Negative infinity.
Negative infinity. So 10 is negative infinity. Now, 11 and 12, x is approaching 3. In 11, we're approaching from the left. In 12, we're approaching from the right. But since 3 has a point, does it really matter which side I'm coming at it from?
No.
No. No matter which side I come at it from, the limit is going to be
0.
0. Yep.
Nice.
So 11 and 12 are both zeros because that's what's happening. As you come closer to 3, You're coming in on this point. Limits are y values, and the y value is 0. So if we didn't have a question like this, but if we were finding the limit as x approaches -1, that would also be 0, right? Yes, it would be. All right, next time we gather, which I don't know when that is, we're going to have a quiz just like that. So you've got 2 different practice problems there. Certainly during flex, I can do another one. But that's exactly what your quiz question's gonna look like, okay? Next time we're together, which I don't have the schedule figured out. Is it still when we're at the end of the day, we don't have it the next day?
I don't think it's tomorrow, but I think it's the
Thursday.
So today it says Thursday.
Yes, Thursday.
Thursday.
Yeah, it'll be Thursday.
This Thursday, yeah. So you got a quiz that's gonna look just like this, gonna have all those questions on it. I mean, obviously different numbers, but same thing. You're gonna sketch something and then answer some limit questions. All right, so what we need to do now is take a look at the next section, 2.7. Homework, since you can't turn it in, you'll just be taking a picture of it and emailing it to me. The 2.6 homework, you'll email it to me by 3:10 tomorrow. I'm just leaving at 3:10, even though I know our day ends earlier. We'll leave at 3:10. Okay? We can also do homework problems during flex if you have a question about that. But what we need to do now is look at our notes, page 9. And this little section, this set of exercises, is fractional things, rational expressions. But now we're not graphing them and all that. Now we are just solving the equation. So, who has an idea about how this equation might get solved?
Would you factor X out? I don't know if that's factor or not. Like, would you subtract 4 to the other side and try to factor it out?
I like the idea of subtracting 4 to the other side because I always like to get 0. But I think it would be much easier for us if we just got rid of the fraction. So how could we get rid of the fraction?
You multiply X on both sides?
Yeah, let's multiply everything by X. So we're going to multiply this by X, we're going to multiply this by X, and we're going to multiply this by X. Now remember, when you multiply this middle one by X, all it does is cancel out. There are no X's left. That's why you did that, to get rid of that denominator. Now, Jacob, I think getting a 0 is a grand idea. Notice when I brought the 4x over, I put it in order there. So what can I do now?
Factor it?
Yep, or if you wanted to, this one does factor, but if you wanted to, you could do the quadratic formula, right? Isn't that a little quadratic equation? But this one does factor quite handily. So I get 2 answers, 3 and 1. Done. That wasn't so bad. How about this next one? What's going to be your strategy here? It's the same kind of problem. What do you think we might want to do?
Multiply everything by X minus 4.
Exactly. So when I multiply this by X minus 4, and this by X minus 4, and that by X minus 4, that's what I'm left with? Would everybody agree with that? Multiply that by x minus 4. Here it cancels, and here it's still 0. So now we've got x squared minus 4x plus 1 if we do our distributive property. Very, very similar to what we had a moment ago, except what?
We have to use the quadratic formula now?
It doesn't factor. So it's okay. We got a quadratic equation. We'll just use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Underneath there, we've got what? 12? Please do not even consider canceling at this point. You must simplify your radical first. If your radical doesn't simplify, you aren't going to be able to cancel. Square root of 12 is 2 root 3. Now you can cancel. So our answers are 2 plus or minus root 3. Not very nice looking answers, but that's what we've got. Everybody okay with that? All right, let's look at the next one. I'm going to save myself a second here, and as I copy it down, I'm going to go ahead and factor this last denominator. Everybody see what I did? I just factored that denominator. Now it's full of fractions. This one has more fractions than the last two have had. But we're going to do this exact same thing. What do you think we're going to multiply by?
The first one you're going to do times x minus 3, and the second one times x minus 1.
Okay, now, I want you to be careful with that. Yes, that's ultimately what's going to happen. But you are not allowed to multiply this by one thing, and this by another thing, and this by another thing. That's not allowed. You know, in an equation, you can multiply everything by 10, or you can multiply everything by 12, but you can't multiply part of it by 10 and part of it by 12. What you're really
like itself, like along with it.
What you're really doing is multiplying by x minus 1, x minus 3. That's what you're really multiplying by. Now, the net effect of that, though, since this is canceling out, the net effect is that the first one has an x minus 3 attached to it, just like you said. But this is what's really going on. Does that make sense to you? I don't ever want to hear you say I multiply the first one by x minus 3 and the second one by x minus 1, because that's illegal. You're multiplying by both of them, but part of it's canceling out. So this is what we've got in the first term. This is what we've got in the second term. And then over here, all we have left is 2. So if we had to talk about this in words, this is the net effect. This is not wrong. That is exactly right. But if we have to talk about it, what we're really doing is multiplying by the common denominator. We're multiplying by the common denominator, and then stuff is canceling out as we go. So we've got 2x squared minus 6x plus x minus 1 equals 2. Let's clean that up. 2x squared minus 5x minus 3 equals 0. Let me double check that. Yeah, I think that's right. So the problem's a lot bigger than the last one. I mean, there's just a lot more stuff. But didn't we end up with the same kind of little quadratic equation? Why, yes, we did, Mrs. Ford. So what are we going to do with this quadratic equation?
We're going to put it in the quadratic formula.
You can put it in the quadratic formula, or I think this one factors. I'm going to try
Okay,
it.
I wasn't sure.
Yeah, I'm going to try it. I think it factors.
Okay.
So I'm just going to do a quick double check. That's going to give me -6 and +1. Yep, that's 5. So absolutely, you could use the quadratic formula, but this one factors. Either way, what am I going to get as my answers? X equals?
-1/2 and 3.
Yep. Now, for the first time today anyway, my extraneous root radar are coming up. Because I know that whatever I put into my original problem cannot make the denominator 0. Do you see what would happen if I put 3 into my original equation? If I put 3 into the original equation, this is going to be trouble, isn't it? So 3 is an extraneous root, and the only answer is the -1/2. I didn't mention that in the last 2 problems, but I was thinking about it, and you need to think about it too. Anytime you have x's in the denominator, remember that whole deal about domain? Can't have zeros in the denominator? That hasn't changed. So if you just take a second and double check to make sure that you don't get any zeros, you're going to be safe. If you forget to check, you might miss something like this. All these problems are going to have denominators, so it always should be in the back of your mind. All right, any question about that one? All right, let's try the next one. Now, some people, right from the beginning, look at the problem the bells are still going off. Look at the problem and say, okay, x cannot be 0 and x cannot be -2. You see what I'm talking about? So I don't know what the answers are going to come out to be when I solve this, but these are what we call the excluded values. These are the things that x cannot be. So I'm going to pay attention to that when I get done here solving it. All right. So what do you think you're going to multiply by? X and x plus 2. That's exactly right. You're going to multiply by x and x plus 2. Now, if you can do this in your head, I am perfectly fine with that. You do not need to write it down. I need you to understand, though, that what's happening behind the scenes is you are multiplying by your common denominator. I factored this and got x plus 2. I have an x plus 2 and an x. So x plus 2 is my common denominator. In the first term, these are going to cancel out and leave me with x minus 3, x plus 2. These are going to cancel here and leave me with just 3x. And the whole shebang is going to cancel there and leave me with plus 6. Now, I also multiplied over here. I didn't write it down, and I should have, but I didn't need really to write it down because since that's a 0, nothing's going to change over there. All right, this is really the critical step. Does anybody have a question about where this came from? Again, you do not have to show everything like I did, but you do have to end up with this. All right, so x squared minus x minus 6 plus 3x plus 6 equals 0. So x squared plus 2x equals 0.
Is it like no solution?
Why do you say that?
Well, because if you factor that out, like it becomes x can't equal 0 and x can't equal -2.
Well,
And
yeah,
those
when
are
you
like excluded values.
exactly when you solve this, it actually comes out to be x equals 0 and x equals -2. But we already said in the beginning that those were the two things it can't be. So you are exactly right. The answer to the question is empty set. Neither of the solutions worked. Was someone saying something? All right, let's turn the page. Last problem of the day. Jessica can finish painting a room in 5 hours. It takes Brenda 6 hours. How long will it take them together? You guys did these in Algebra 1. They're called work problems. They're different than the work problems you do in physics class, but we call these work problems in Algebra 1. And the setup for them is always 1 over the first guy's time alone plus 1 over the second guy's time alone equals 1 over their time together. So if you can just remember that general formula, these are going to be easy problems for you. So what do we got? We got Jessica can do it in 5 hours, so we're going to start with 1 over 5. We got Brenda doing it in 6 hours, so that's 1 over 6. And then this will be 1 over what?
11.
X. Oh my goodness, no, we do not add fractions by adding their denominator. What is the question in the problem? How long does it take them together? So 1 over x. Hang on. Now we're going to multiply through by what? What is my common denominator? What's going to clear all this stuff out?
30x.
Yep, 30x. You need the x too, so you're going to multiply everything by 30x. That's your common denominator. 5 times 6 times x. There are lots of common denominators, so don't worry. Just multiply by something that's going to cancel all this out. Will a 30 cancel out of 5? Yep, and leave you with 6x. Will a 30 cancel out of 6? Yep, and leave you with 5x. Will a 30x cancel out an x? Yep, and leave you with 30. So 11x equals 30. And the answer is 30/11 hours. So if they work together, it will take them 30/11 hours. Put a star by this. 1 over alone plus 1 over alone equals 1 over together. And you are going to have an easy time of it if you just remember that little formula. Okay, everybody? All right, we got homework due tomorrow by the end of the day, school day. We have a quiz on, you said Thursday, 1 problem just like these. And then we have our paper due on Friday, so it's a busy week. All right, anybody who wants to stay on, stay on. Anybody who wants to leave, let's say a quick little blessing. What did they always say at the end of the day?
like Hail Mary, I think.
Well, yeah. What did he say first? Lord, I surrender myself to you. Please take care of everything.
Yeah.
Okay.
Yeah.
All right, let's do a quick Hail Mary. In the name of the Father, Son, and the Holy Spirit. Hail Mary, full of grace, the Lord is with thee. Blessed are you among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. In the name of the Father, and the Son, and the Holy Spirit, I'll see you guys tomorrow. Stay on if you want to stay for flex.
Thank you.
All right.
Thank you.
Stay
Thank
if
you.
you want to stay. All right.
And I'll see you tomorrow morning for that test.
Yeah, you and someone else. I can't remember, but
Yep.
yes. Yep.
All right, sounds good. Have
All
a
right.
nice day.
All right, bye-bye. All right. So let's wait a second and see if anybody else is going to join us. Give them a minute to get out of their last class. What is today?